Hello, I am Jackson Ju, and today I will be teaching you about vapor pressure and volatility. So before I go over vapor pressure, first I want to review the intermolecular forces with you. So the first strongest is our ionic bond, the second strongest are hydrogen bonds, the third strongest are dipole-dipole interactions, and the fourth strongest or the weakest are London dispersion forces. So ionic bonds. Ionic bonds occur between a metal and a non-metal. For this example, we will be using sodium and fluorine. In sodium, there is only one valence electron, and both atoms want to have a full octet. So what happens is the sodium donates its one valence electron to fluorine, and thus they both have a full octet, and this forms an ionic bond between the two. So this will happen to a lot of sodium and fluorine atoms packed together, and that will create an ionic salt. So next are hydrogen bonds. Hydrogen bonds occur between the hydrogen of a molecule and either the fluorine, oxygen, or nitrogen of another one of those molecules. In this example, we will be using water, and as you can see, the hydrogen of this water molecule is forming a hydrogen bond with the oxygen of this water molecule. And the same is going with this molecule and this molecule. And the next we have dipole-dipole interactions. So these are intermolecular forces that occur between two polar molecules. See, here we have the negative end of hydrogen chloride forming a bond with the positive end of the other hydrogen chloride, right here. So, London dispersion forces. London dispersion forces are the weakest of the intermolecular forces, and they exist between all molecules. While many molecules may experience multiple kinds of intermolecular forces, no matter what, they will always experience London dispersion forces. So, what is vapor pressure? So to explain this, I will make a particle view diagram for you. Here we have a liquid, and in a liquid, there are molecules that are moving at a relatively fast pace. Not quite as fast as gas, but faster than solids, and they are free-flowing. However, they still experience intermolecular forces between each molecule. And so what vapor pressure is when the molecule hits the side of the container and it hits with enough force and kinetic energy to break the intermolecular forces with the other molecules in the container and become a gas. Okay? So, this is not to be confused with boiling. Boiling is the same process, but there is energy inputted, while vapor pressure is this process, but is when the system is left alone, and there's no external energy being inputted. So, there are two big factors that contribute to vapor pressure, one of which is temperature. So, the temperature of a substance is its average kinetic energy. So, the higher the pressure of this, the higher the kinetic energy and the faster the particles will be moving. So if the particles are moving faster and with more kinetic energy, it'll collide with the container with more energy and have enough kinetic force to break the bonds. Okay? And then the second is intermolecular forces themselves. So the stronger the intermolecular force, the harder it will be to break. Thus, the vapor pressure will be much lower for stronger intermolecular forces such as ionic bonds and hydrogen bonds, while the vapor pressure may be higher for intermolecular forces experienced with dipole-dipole interactions and London dispersion forces. Okay. So volatility. Volatility is how readily something evaporates. Okay. So something with high temperature will have a high volatility. Okay, and then something with strong intermolecular forces will have a lower volatility because the molecules will not want to evaporate very readily. Okay. And so an example of this is nail polish remover. Nail polish remover contains a molecule called acetone. And acetone only experiences London dispersion forces. Therefore, it is highly, highly volatile. So leaving the cap off of nail polish, like is seen in this picture, will cause the acetone in the nail polish remover to leave the container and the nail polish remover to deplete. That is why people who have nail polish remover and use it put the cap on immediately after using it, because if you leave it off, the nail polish will deplete and you'll have to go buy more, which costs you a lot of money, and nobody likes to lose money. Okay, the next example we have for this is water. Water is an extremely non-volatile substance. So if you take the cap off of a water bottle, the water in the bottle will not readily evaporate. And if you leave it for maybe a few hours, the same amount of water will likely stay in the bottle. And this is due to the hydrogen bonding that is exhibited between the water molecules. Knowing that it's one of the second strongest intermolecular force, it is much more difficult to break. Okay, so that is all I have for you today. Thank you for tuning into my video, and go get volatile.